Hi everyone, wow. What an amazing event. Thank you so much for having me here today, for coming to listen to what I have to say. I want to also thank Mark and all of the amazing organizers of this event. Thank you so much for putting this together. And I want to thank the speakers for being so inspiring and creative and for all of their imagination. My name is Shirley, and I'm an independent creator of data visualizations. I started out my career as a software engineer at a big data company back in 2012, where I first learned about D3 and how to use it to create data visualizations. And I love that so much that in 2014, I took my second role as a front-end developer for a data visualization product. And I love that so much that in 2016, I decided to take the jump, take the leap, quit my full-time job, and try my hand at freelancing, doing solely data visualization. And in the last 3 years, I've had the amazing opportunity to work with a set of brilliant clients, mostly in the tech, media, and journalism industries, and work with them to tell visual stories with their data, as well as a personal project called Data Sketches with my really great friend Nadi, where we create 12 different data visualizations on different topics of our choosing and write about our process from start to finish. So today, I want to share with you some of those past projects, but more importantly, about the lessons that I've learned creating them throughout the whole data, design, and code process. So let's get started. The very first step of a data visualization is, of course, the data. And over the years, I've learned that when I start on a data visualization project, the very first thing is that I find a curiosity. I go out and find a topic that I'm interested in because I know that as long as I have that interest, it will motivate me throughout the rest of the project. And as long as I have that curiosity, I know that I can get really creative and get any data set I want from out there to satisfy that curiosity. Back in 2016, one of the first client projects I ever took was with The Pudding, and I created this article with them called An Interactive Visualization of Every Line in Hamilton, which is a musical. I don't know if anybody here has heard of it or love it. Thank you, yes, for that support. And this project really stemmed from the fact that in 2016, I was so obsessed with this musical. I had it on repeat for about half the year that my fiance was like, why don't you just make a visualization about it? So I did. And each of these dots represent a set of lyrics from the musical sung by a character. And as the reader scrolls down the screen, I present them with the analysis I did for the musical and all of the interesting insights and patterns I learned about the characters through my analysis, until they get to the very end and I give them the exploratory tool that I use to do my own analysis, where they can go and filter by any set of characters, conversations, and themes, and look into the remaining lines and songs to do their own analysis. And this project really started because of my obsession, and as I kept on listening to these songs, I wondered, how do the relationships change between these characters throughout the musical? As well as, what recurring phrases are there, and who are they associated with? And as you can probably imagine, none of this data existed elsewhere. And so I had to go and create my own data set. First time going through the lyrics and noting all of the recurring phrases throughout. And then grouping each of those phrases into broad general themes, and then going through all of the lyrics again a second time manually entering all of those themes, and at the same time, noting any characters and conversations that they were having. I then wrote a script to aggregate all of that metadata by song and line number to get my final data set. And this and many similar projects have taught me that as long as I have that curiosity, I can always go out and get the data I need, whether it's through manual data entry or APIs or automated scripts, as long as I make sure to stay within the bounds of the law. And now that we have the data, the second lesson, very important, that I've learned, is to make sure to always explore the data before starting on the design. This is a personal project I did for Data Sketches called 4 Years of Vacations in 20,000 Colors, where I took 4,000 images from my 13 vacations, took out the 5 primary colors, the 5 most frequently occurring colors from each of those images, grouped those colors by the trip that it was taken on, and arranged them by the day of the trip that they were taken on. And this is one of my absolute personal favorites because I've gotten to learn a lot about myself through this project, which is that I've always known that when I go on vacation, I love taking pictures of nature. So all the lakes and oceans and forests and mountains and all of these greens and blues made a lot of sense to me, but I was really confused as to why there were so many reds and purples. And when I took a look at the underlying data set, the underlying photos, it turns out that they were all food pictures. So apparently in this 2014 trip to Japan, all we did was eat. Yeah, it's a little bit embarrassing, but for that reason, this is one of my personal favorite data visualizations. But when I first started on this project, it actually didn't start out so well. It actually started out disastrously. This is one of my really rough sketches from when I first started on the design. And the question I had for the data set was I wanted to know where and when do I take my pictures? Had really good intentions. I just wanted to know about myself. And so I drew this rough sketch of the x-axis being time of day, and as well as extends into like the geographies, which continents maybe I took my pictures in, and then the y-axis was the year that I took these pictures. Had the best of intentions. But what I didn't do was look into my data before I started. I had just spent so long collecting all of the data. I felt so exhausted. I didn't want anything with the data. And I did not look into the data set and try and understand it at all before I sketched out this design. So this is what happened. This is what happened when I plugged in my data according to my design. I've come to really love this piece. I now call this my contemporary postmodern art piece, Man Peeing into Puddle and or Kidney Bean. Yeah, I've come to really love it and accept it. I even show it at conferences now. But when I first got this, I was like, okay, like this can't be the final product. So I had to really take a step back and reevaluate and take a look at the data set and ask myself, what metadata does each photo, does each of those data points have? Then I realized, for example, that each of these colors had the metadata of the trip that it was taken on. So I tried grouping by them. I had the information of the day that it was taken on. So I decided to map that day to the angle around the group. And of course, because they're colors, I also had the hue, saturation, and lightness. And then I decided to map that hue information to the radius, so you can get this kind of nice gradient going from green to red out. And I learned this really important lesson that I should always list out my data attributes and assign them to the right visual channels So for example, for quantitative attributes, like the day and the saturation and the hue, I can map those quantitative attributes to visual channels like XY positions, radius, angle, width, height. And for the categorical data attributes, I can map them to visual channels like colors and shapes. And always make sure to watch out for those extremes, those outliers. But I've also learned over the years that creating compelling data visualizations take more than just assigning the right data attribute to the right visual channels. And I found that some of the most compelling of these visualizations have a masterful grasp of visual metaphors. Like when the New York Times decided to visualize class mobility as just dots, literally dots on the screen animating and rising, or dots falling down. Or any number of articles that have decided to use these red dripping bars to describe data sets about deaths or murders. And I found that these subtle uses of metaphor really help the reader get a quicker understanding of what the underlying data set is, as well as reduce that initial learning curve for understanding a visualization that they might not have seen before. And in a world where our readers are just have thousands of things on their screens vying for their attention, I found that it's important to design to maximize for their delight, to give them little subtle, sometimes even little flashy details that will hopefully motivate them to keep scrolling through the story. In fall of 2017, I had this amazing opportunity to work with the US Guardian team and my friend Nadi on this article called Bust Out, about how American cities move their homeless from city to city. The Guardian team went and obtained data from 16 different cities who gave them more than 20,000 data points about homeless people that were bused from one city to another. And it's an amazing piece of investigative journalism where the Guardian team took a look at cities, and cities that not only bused their homeless, but also flew their homeless overseas. And they took a look at the economic situations of these cities, as well as the relatives and acquaintances that might have received these people on the other side. And finally, about the financial motivation that these cities might have for these programs. Taking, for example, that in San Francisco, over the course of 12 years, more than 10,000 people were bused out of that city. And if they weren't, San Francisco would have been financially responsible for more than approximately 18,000 people. Nadia and I got to make a variety of visualizations for this piece. But today, the one that I want to concentrate on with you is the visualization for New York. New York was a very unique case in that it's the only American city that not only buses their homeless people, but also flies them overseas. And we had two main goals for this visualization. Number one, to highlight the furthest flights that New York has bought for their homeless. And number two, to show the most frequent destinations for New York's homeless people. And so for the first goal of highlighting the furthest flights, the very first obvious answer is to use a map. But we didn't want to use a map not only because we had already used a map for our initial visualization to introduce the dataset itself, but more importantly because maps are just inherently not as great for comparing relative distances between different cities, different starting and ending cities. And so the next obvious answer is a bar chart, because bar charts are made to show and compare quantitative differences. But we wanted to give our readers something a little bit more than that. And so we settled on this visual metaphor of a person starting out and taking off from their origin city and flying across the screen to land at their destination. And it was very straightforward to expand this metaphor to our second goal of showing the most frequent destinations for New York's homeless people, by drawing and representing these people as dots that flew across the screen along these arcs. But even then, it took many, many, many iterations of subtle changes to get the animation to a point that I could be satisfied with, that could, I hoped, delight the user as they scrolled, but also not bog them down with how long it took. And so this is my final visualization, my animated visualization, where each arc represents a destination, and each bubble increases in size as more and more people are sent there. So far, we've talked a lot about getting the data and for the design. And now I want to talk a little bit about the code. For the past year or so, I've been joking around a lot that data visualization is basically just drawing shapes on the screen, and drawing shapes is basically just SVG paths and trigonometry. But this is actually really true. Even though I just joke around about it, I find that it's very true. And I've also found that the best thing that I've done for myself is to go and learn and get really familiar with how SVG paths work, because I've learned that when I have all of those mastered, then I can truly create any shape, any line that I can dream up on the screen. This is another project I did for data sketches called Film Flowers, where I've reimagined the top blockbuster, summer blockbuster movies of the last 3 decades as flowers, where each of the petals are parental guidance ratings, each of the colors are genres, and the number and the size of the flowers represent their IMDb rating out of 10. And there's some really beautiful ones in here, like The Dark Knight Rises and Inception, and I have a really soft spot for Harry Potter. But my absolute favorite that I show everyone at every conference is the 1997 Batman and Robin. Because of how tiny and teensy and cute it is. I've never seen it. I kind of want to. I just heard you're lucky. But when I first published this project, I got some feedback asking me, how hard was it to do that? How hard was it to create those flowers? And the answer is, it's actually quite straightforward as long as you have a good grasp of this thing called the cubic Bezier curve command. And I want to show you how that works. So the way that I like thinking about them is that when I want to draw a curve, I start out with my starting point, in this case 0, 0, and I'm drawing a straight line down to my ending point, that purple little point. And what I'm doing is I'm taking that blue and green anchor points, and I'm just dragging out those anchors until I get the curve I want. I draw 2 lines, draw another curve on the other side, create 6 more of these petals, rotate them around, put a little bit of color, And that's what it takes to draw that flower. Oh, thank you. Thank you. But just drawing shapes onto the screen doesn't make it a data visualization. To create a data visualization, you need to translate data onto the screen space. And for that, we need the help of some JavaScript libraries. And while I think that D3 is the definitive JavaScript library for creating data visualizations on the web, I also think that there are subsets of D3 that are better done with other JavaScript libraries. And so over the years, I've experimented with different libraries, and I've come to the conclusion that as of right now, my favorite is to use D3 with Vue and GreenSock because it leads to more efficient coding. And to try to convince you of that, I have this demo visualization of, again, the top blockbuster movies, but this time of the last decade. And there's kind of two parts to this visualization. The first part is the bottom part with the histograms. And these histograms show you the distribution of Metascores as well as the distribution for the box office figures. And then there's this top part that's kind of like the little custom part of the visualization that I don't have a name for, and I just call it an area chart. But each of these curves represent a movie. And each movie rises up above this line if the box office figure is above the median box office figure, and droops down if it's below. And I also have this interaction where I can brush to filter each of those movies by the range of Metascore, as well as brush the box office figure. So you can do some like really fun things with this. Like you can be like, I want to know all of the things that were below the median, but like did really well. And you can be like, oh, that's WALL-E, which makes me a little bit sad. WALL-E and Gravity and Inside Out, that they didn't do better. Then you can also be like, I want to know those ones that like did really well in the box office, but like really not well in the Metascores. And that's like, oh wait, no, hold on. Let me do this, sorry. This, and then I was supposed to do this, okay. Okay, so that, and then, yeah, really not well, sorry. Below 50, not well. And you can see that it's like Transformers, and Transformers, and Suicide Squad. But today what I want to do with you is live code this to show you that everything that you've seen so far is pretty attainable. So yeah, this is the part where I live code in front of you. Thank you. Oh, thank you. Thank you so much. So I, for the sake of time, already have the kind of bottom histograms done, and I want to code this upper area chart, the custom part with you. And so let's get started with the code. So this is my app.view, and it's my root component. And what I've done is, within the JavaScript, I've gone and fetched my movies data set. And I've gone and registered that in this data function so that we can keep track of any changes made on that data set. And in this template section, all I've done is gone and created an area chart and a histogram, called those components. And then here's my area chart component. And what we're going to do is we have this movies data set passed down from the app.view, the parent, and then we're watching for any changes in that movies data set, and we're going to go and calculate the scales. And by that, I mean that we're going to use D3 to translate the data into screen space, and then we're going to use those scales to calculate the data for drawing onto the screen. And as I mentioned before, it's just all about mapping. And so we're going to map the X position, the Y position, and the color. Okay, so let's get started doing that. So what I want to do with the X position is that I want to map it to the date. And for the date, I want to use each movie's release date But because we're drawing those curves, and you notice that like there's the tall part, but then there's little points that are, I've set it as 2 months before and 2 months after. So what we want to do is go and get the min and max date, use D3 to go through the data set and tell it we want the date, and then create the X scale using D3 scale time. And scale time, what it does is you tell it that it's an input that's temporal and an output that's a continuous. So then I tell it my input, and that input needs to be the minimum release date minus 2 months and the maximum date plus 2 months. And we're going to tell it that we want to map those two numbers, the minimum date, to our left-hand side. So let's say I have this margin left number, and then I want to map the maximum to my right-hand side. So that would be the width minus, like, give it a little bit of margin. And then I want to calculate my Y position. So what I want to do is go and calculate my median box office figure, because remember that my Y position is the difference between each movie's box office figure minus the median box office. So go and calculate that first. So that's my box office figure. And then I want to go and create the Y scale. So go and get the min and max box office, but subtract the median box office from that. And then create the Y scale. And this time use a linear scale. That means a continuous input and a continuous output, and map them 1 to 1. So the domain is min and max box dot range, and what I want to do is map the lowest box office figure to the very bottom of the visualization. So that should be this dot height minus margin dot bottom, and then my highest box office to the top of my visualization. So let's just only use margin. Remember, and then translate that median box office figure to a Y position. And then the final scale is with the color. And with the color, what we want to use is the min and maximum score, metascore for each movie. Score. And then we're going to use a D3 scale called scale sequential, and a interpolator called interpolate Verdis that I'll explain in a bit. Pass in, say that our input is the minimum and maximum score, and what this is doing is mapping that continuous input to this continuous range of colors called interpolate Verdis. Finally, create my area generator in D3 area, and what D3 area does is that when we pass it a series of points, D3 goes and draws a line between each of those points. And then we need to tell it a baseline to fill that area until. So let's tell it a baseline of that median, the Y position of that median box office figure. And then finally, let's tell it the curve that we want them to, like instead of, when we connect those points, instead of just linear, like lines connecting them, let's tell them the curve that we want. And so D3 shifts with some curves, and I'm just gonna use one called D3 curve Catmull ROM, only because I think it's pretty. And so that's all the setup we need for D3. And now let's go and actually use D3 to translate that data. So what we want is, I'm gonna call it arcs, and then for each movie, we want to return the ID for it, then the SVG path string to draw that curve. And so we're gonna use the area generator. And like I said before, area generator takes a set of points, and the points that we want to use for the curves is 3 points. The first one being the the release date minus 2 months. So let's go and get that. So this is the release date minus 2 months, and then translate that into the X position. And that should be at the baseline. So we'll use the Y position for the baseline. The middle point should be the kind of top part where the X position is the release date and the Y position is that box office figure. So let's do that. Wait, no, it's just the date. And then the Y position, we're using the box office figure minus the median box. And finally, to close out the curve, we just want to draw another point 2 months after the release date. Give it a fill, and that's the color scale we used earlier, pass in the score. And if we've done all of those calculations correctly, if I console log the arcs, then hopefully, oh yes, okay. So that's the 98. Wait. The fill and the path string. So this is a really ugly path string, but now we can use that to draw the curves. And this is my absolute favorite part, because in View, if I go to template and I say that I want to draw an SVG path for each of those arc data things that I calculated, and I want to, for the key, I want to use the ID. For the path string, use the path I just calculated, fill it with the color, give it a white stroke just so we can see the overlapping things. And with just this one line replaces D3's enter, update, exit pattern, which if you know that pattern, you know that it's actually dozens of lines to do this exact same thing. And so with this one line, if it works, it's not working. So it seems, it's because my baseline used the median box for some reason. There it is. Thank you. And the next part I want to show you is that interaction of brushing. And so I want to also show you, like, it looks like a pretty sophisticated interaction that might take a long time to implement, but I want to show you that it's much more straightforward when it's with D3 and View. And to do this, let's start out with that histogram component. And what I have here is that in the histogram component, I have this SVG group element that I've given a reference called brush. And then down here, I've created a D3 brush instance. And all I have to do is use D3 to select that brush, that group element, call D3's brush instance, and then D3 will go in and create all of the visuals, all of the dominant elements necessary to have this interaction, which I think is pretty amazing. But you might notice that none of the movies are getting filtered, and we have to implement that logic ourselves. So to do that, we want to, I have these functions that are registered on these brush events. And so let's go down to that brush end function, and how it works is when D3 gets this event, this brush event, what it does is it remembers the X position, the starting X position and the ending X position, the X1 and X2 of these bounds. So we're going to say that if we have those bounds, and it's remembered in a thing called d3.event.selection, then let's go and get those X positions. And then we want to update the bounds with, we want to translate that back from the X position back into the original data. And to do that, we say xscale.invert, plug in that X1, do the same thing with X2. And then we say that we want to tell our parent component all of this information. So I actually have this function called update filters that I've gotten from my parents. I'm just going to say that I want the ID of that histogram, whether it's a Metascore or box office figure, and then pass in the bounds. And if I've done that correctly, then down here in my app.view, in my update filters function, I should be able to say console.log filter. And then I'm getting this information that I've filtered the Metascore, and now the bounds are between 57 and 75. And now is kind of the hard part. So, okay, hold on. Filters, and then let me go and remember it. First things first, let me go and remember, just like shove that new filter in to what I remember as the filters. And then this is kind of the hard part where I need to figure out, take the movies data set and filter them down. And the way that I want to filter them is that I want to, for each movie, go through all of the filters and make sure that that movie is within the boundaries of those filters. So let's do this. Okay, go through each of the filters and get the bounds and the name of the filter and make sure that that movie is going to be kept either if it's not filtered, or if, okay, it has to be within the bounds. So it's within the bounds, the filter, and within the two bounds. And if I've done that correctly, then what should happen is that this data set, this filtered, the original data set has 98 movies, I think, and every time I filter, the length of the array should be smaller than that. And so, let's see, yes, yeah, so there's 38, it's getting filtered, and you know because the histograms are getting filtered. But you'll notice that the curves aren't being filtered. So let's go in and fix that, one last step. Go back into the area chart, and all I have to do is say that I also want to listen to changes on the filtered data set. And now this time around, all I want to do is recalculate the data for each movie. And down here in calculate data, instead of using this dot movies, I'm going to use this dot filters. And with these two line changes, there we go. Thank you. And the one final step is that you've noticed that, you might notice that these movies up there aren't being animated. So let's use green sock to do that animation. We're going to go back into our area chart, and then we're going to just put this path into these kind of like two little transition groups. And with these transition groups, I'm telling View that I wanted to do a certain thing when these paths are being entered, and another certain thing when these paths are being exited. And then down here, I have these two functions where I'm using green sock to animate the curves up when they're being entered, and animated them down when they're being exited. And with those three parts, they get animated. Thank you. Thank you. So yeah, that's the three parts. And so the way that I like to think about it is that I use D3 for scales and shapes so that I can translate my data into my screen space. And I like to use D3 for axes and brushes for common data visualization patterns because I think that D3 does this better than any other library out there. And I like to use view for their reactivity system to replace D3's enter, update, exit pattern, as well as the dispatch system so that I can hook up different parts of the page and make them interact with each other. And finally, I like to use greensock and use greensock's tween with view to replace D3's transition and to use timeline for more complicated multi-step animations. And all three of these together, I've found, have led to fewer lines of code and faster development for me. So I've spent a really long time talking about kind of like the past and present of my work. And now, if you could just indulge me for like a few more minutes, apparently I have 4 minutes, I want to share with you my hopes for the future of my work. And I have 2 goals that I've been working on since the beginning of this year. The first being that for the last 3 years, I've been working with really amazing clients, brilliant clients, but always on stories that are important to them. And so starting this year, I want to try and work more on projects that tell stories that are important to me. And those stories are about representation, stories about being a woman in tech, about representation of women in media, in leadership, and history. I'm also Chinese American, and I want to start working on stories, telling stories about the Asian American or Asian Western experience. And the second goal I've made for myself is that I want to start creating immersive, interactive, and most importantly, physical experiences. And the reason for this is that I found that there's something really magical and special to me when I step into a piece of work, a piece of art, and it just surrounds me, all around me, instead of being on like a tiny little screen that we're staring at, and it just comes to life around me. And I think there's something really powerful about that, where I think it just helps me get in that moment and really appreciate that moment and really appreciate that piece of art, and maybe even take something from it and learn from it. And I've come to a point where I really want to create that myself. And I'm hoping to do both of that with everything that I've learned so far with data and software, and with everything I want to learn in the future with hardware and physical materials to make those 2 dreams come true. So last December, I created this project called Legends about the 51 women Nobel laureates since 1901. And each of these women are represented as these crystals. This is Malala, my favorite. And they are sized by their quote-unquote influence, which is the number of Wikipedia articles that mention them. They're colored by the category of their award, and they're also the number of faces that they have is the number of references at the bottom of their Wikipedia article, because they're complex and multifaceted. Get it? Okay, sorry. They're multifaceted. You can. I'm really corny. And you can walk through each of these. You can walk through and read about these women and their life accomplishments, but you can also fly up and see the decades in which they've won their awards, and see that for the first 70 years or so, there weren't that many women, and also there were 2 whole decades that no women were awarded any Nobel Prizes. And if you take a look around, all of these yellow stars hovering around them, each of these stars represent one of 853 men that have won the same award in those same amount of time. And I did this project, one, because I realized that if I want to start getting into physical installations, then I need to get better about thinking in the 3rd dimension. But second, because this is such an important topic to me, and I really hope that I can create physical installations that people can walk through and really kind of learn about each of these women, maybe hopefully take something away from it. And so 2 weeks ago, I got to take my very, very first baby step towards this dream. And I got to work with my studio mate, the brilliant, talented, super creative Alice Lee. And we got to make this, we made this window display for our studio office for a pop-up show that we were doing. And each of these flowers are one of the women Nobel laureates, but because we didn't have enough room, it's only the last 3 decades. There's 29 of them in the last 3 decades. And that flower I'm holding is Malala. And the story behind this one is this is a girl dreaming about all of these amazing women, and she has a watering can so that she can water and grow her own dreams. And we've kind of cheekily decided to call this like flower power. And this is our kind of like first prototype version, and we're hoping to iterate on this more and more. And I kind of love this. Like we joked around that the second version we'll call it like flower power squared, and like third version would be like flower power cubed. Do you get it? Yeah. Okay. And then we were like, wait, what do we call anything after that? I don't know, quadrupled, and then we don't know after that. But I'm really cheesy. But I'm just really excited. I'm really, really excited about this kind of first step. And I want to thank you so much for listening to my story, and thank you so much for all of the inspiration that this conference has been. Thank you.